All right, let's talk about something that drives every programmer crazy: debugging. Today, we're going to flip the script. We're going to take that whole frustrating experience and turn it into something more like a detective story, a puzzle that you actually have the tools to solve.
You know the feeling. You're just staring at your screen, your code is broken, and you have absolutely no clue why. But what if I told you that bug isn't a sign of failure? It's a mystery, and your computer is actually leaving you clues, practically begging you to figure it out.
Look, every single person who writes code, from the absolute beginner to the most senior engineer, deals with bugs. It's just part of the job. So the trick isn't to somehow write perfect bug-free code, because that's impossible. The trick is to get really, really good at hunting them down. It's a skill, and it's a skill we can learn.
So here's the mindset I want you to adopt. Your code? It's a crime scene. Something has gone wrong. The bug is the culprit hiding somewhere in the shadows. And you are the detective on the case. It's your job to piece it all together. So, let's get to work. Every good investigation has to start somewhere, right? It starts with that first piece of evidence. And in our world, that's the error message. I know it can look super intimidating, like a big wall of angry red text. But it's not bad at you. It's actually the most important clue the system can possibly give you. That wall of text, the traceback, isn't just random chaos. It's a structured report, and you can break it down into 3 simple steps. First, just scan for the file and the line number. That tells you the exact location of the crime scene. Step 2, find the error type. Is it a type error, a name error? This tells you the kind of crime that was committed. And finally, step 3, just read the little description at the end. That's the computer telling you exactly what it thinks went wrong.
Seriously, we need to completely reframe how we think about these things. An error message is not the computer telling you you're a bad programmer. Not at all. It's a treasure map. It's pointing with a giant X right to the spot where the problem is. If you just follow the map, you're going to find the fix.
Okay, detective. You've used the error message to find the right street, the right house. But now you need to look closer. And for that, we turn to one of the simplest, most powerful tools you have: the print statement. Think of it as your magnifying glass. It lets you peek inside your code while it's running and see what's actually happening in there.
So let's picture this. You've got a simple function. Maybe it's supposed to add 2 numbers. You give it 2 and 2, but for some reason, it's giving you back 22 instead of 4. You've read the code over and over, and it looks totally fine on the surface.
And this is that moment of pure frustration, isn't it? The logic seems perfectly fine, but the result is just wrong. Well, a good detective doesn't just stand there staring at the room. They start dusting for fingerprints. How do we see what the values inside that function really are?
And check this out. This is the magic of that little magnifying glass. On the left, there's our mystery code. On the right, we've just dropped in a single print statement to check on a variable. And bam, there it is. The value isn't what we thought it was at all. The entire mystery solved in a second with 1 line of code.
Now, print statements are fantastic for quick checks, but for those really tricky, complex cases, you need to bring in the heavy equipment. It's time to take the evidence back to the forensics lab, and that is your professional debugger, which is probably already built right into your code editor. Using a debugger is like gaining superpowers. You can set what's called a breakpoint to literally pause your code at any line you choose. Then you can step through it, 1 line at a time, watching everything unfold in slow motion. You can inspect any variable, see its value change in real time, and even look at the call stack to trace the exact path your program took to get into this mess. It's like having a frame-by-frame video replay of the entire event.
So up until now, we've basically been crime fighters, right? We're solving bugs after they've already happened. But the best detectives also know a thing or two about crime prevention. In the coding world, that means writing code that's clean, predictable, and easy to read. And for Python programmers, our rulebook for that is called PEP 8.
So what is PEP 8? Think of it as the official style guide for Python. It covers all the little things, like how to name your variables, where to put spaces, that kind of stuff. And the point isn't just to make your code look nice. The point is to make it consistent so that any human, especially your future self, can read it and immediately understand what's going on.
I mean, just look at the difference here. On the left, you've got code that technically works, but it's a total mess. It's hard to follow, and a tiny bug could be hiding in there and you'd never see it. Now look at the right. It's the exact same logic, but it's clean, it's organized, it follows the rules. It's just easier to understand. Bugs have a really hard time hiding in clean code.
And you have to remember this. You aren't just writing clean code for your teammates or your boss. You are writing it for yourself 6 months from now when you have to come back to this project and have no memory of what you were thinking. Trust me, your future self is going to be so grateful you took the time to keep things tidy.
At the end of the day, being a great programmer has nothing to do with being perfect. It's about being a great problem solver, a great detective. It's about having the right mindset and the right tools to systematically hunt down any problem that comes your way.
So now you have the detective's toolkit. You know how to read the clues in an error message, you've got your magnifying glass with the print statement, you can bring in the forensics lab with a debugger, and you know how to practice crime prevention with clean code. The only question left is, what mystery are you going to solve first?